Hello, welcome to the very first lesson in this course. I am Professor and I'm happy to be your tutor. In this lecture series, we will use the light bulb as a test device for almost all the circuits that we build. However, the knowledge you will acquire is not only applicable to light bulbs but all devices unless otherwise stated. So let's start by talking about light bulbs and why we need them. Now, during the day when the sun is up high in the sky, we go about our duties freely without any difficulty in seeing, of course, unless you have issues with your eye. However, as night falls, seeing becomes difficult. Now, have you ever asked yourself why that is the case? Well, let's find out. So the earth performs two types of motion. The first is it revolves around the sun, and the second is it rotates about its axis. The revolution of the earth around the sun is what causes seasonal changes. So autumn, summer, winter, all these things are caused by the revolution of the earth, and the rotation of the earth is responsible for day and night. Okay, so that is why it appears that the sun rises in the morning, the sun will rise in the east, and it will set in the west, right? But then take note that the sun is always shining, and between the earth and the sun, it is the earth that moves around the sun. Okay, now we experience darkness because as the earth rotates, it moves our position on the earth's surface away from the direction of the sun. Now, the energy from the sun reaches our environment in the form of electromagnetic waves. Okay, now these electromagnetic waves is a spectrum of energy. So take it as different levels of energies traveling together. Okay, and the energies are associated with some frequencies, and the frequencies are associated with some wavelength. So sometimes you hear people talk about frequencies or wavelengths. They just represent not the same thing, but they are speaking about the same context, right? Now, there is a portion of the electromagnetic spectrum that is visible to our naked eye. That is what we call light. There are other portions that are invisible to our naked eyes. Some portions of this spectrum have very high energies. For instance, the gamma rays, X rays, and the ultraviolet rays. Okay. Now, the visible and the infrared regions have relatively lower energies. Okay. The energy of the visible portion, which we call light, is what makes it possible to see things. So, what we call darkness is actually the absence of this visible light. Okay. Now, take note that darkness is not devoid of other electromagnetic waves, okay? Because the human eye is only sensitive to the visible region, that is why when this energy from this visible region is not available, we don't see anything. All we see is darkness. However, there are some animals that can see in the infrared region. So when human beings see darkness, those animals will actually be able to spot objects in their environment, right? Now, this is because it is a known fact that any object whose temperature is above zero Kelvin, that's absolute zero, emits some amount of thermal radiations. And infrared happens to be an example of a thermal radiations. Hence, if an object emits the right wavelength of infrared, which the animal can see, then the animal will be able to see that there is an object here, irrespective of the fact that there is no visible light. Now, during the day, as the solar radiations travel to the Earth's surface, the very energetic parts of the radiation, as I said, the gamma, the X ray, the UV, are absorbed, scattered, or reflected by the various layers in the atmosphere and the clouds. Now, this is very important because if these radiations get a chance to enter into our atmosphere, that will be disaster. Okay. Now, the objects in our environment absorb some of these rays that finally reaches the surface of the earth and may reflect or re-emit some of the energy. Okay. Now, it happens that the color of an object is the portion of these visible electromagnetic waves that it reflects or re-emit. Now, there is more to this, but that's not the subject of interest, so I won't go further. So when an object appears as green or when an object has the color green, it means that it absorbs all the wavelengths except green, hence we see it as green, okay? That is, in the absence of light, there will be no energy reflected or re-emitted from the object to our eyes. Hence, we cannot see that object. So, in the absence of sunlight, such as night falls, we create our own light. In the olden days, they used things like burning torches, candles, lanterns, firewood to produce light. Now, these weren't ideal because of the smoke and the ashes they produce and the potential to start a fire outbreak, among many others. One important or essential factor is the fact that the candles and burning torches actually depend on oxygen to burn. And we know that human beings also need oxygen to breathe, right? Therefore, in a closed room, there is going to be competition for oxygen, and this is not good for human health. So, fast forward, scientists and engineers created the light bulb. The light bulb has many advantages over the candle and the glowing torches. In that, first, it does not produce smoke or ashes, right? And it does not require oxygen to produce light. Now, the question is, how does the light bulb work, right? This is a question that I would answer in bits as the course progresses, but it all starts with the universe. Now, I like the way NASA put it. The universe is everything. It includes all of space and all of matter and energy that space contains. It includes time itself and it includes you. Okay. Now, right now we are interested in matter, so let's confine our area of interest to the planet Earth. Maybe later we can join Elon to Mars. Now, matter is everything around us. A formal definition is anything that has mass and occupies space. So, what examples come to mind? Let's start with you. The chair you are probably sitting on, the water you drink, the air you breathe, any insect, computers, etc. Now, there are many states of matter. Matter manifests itself in different ways, right? But on the surface of the earth, three common states are known. We have solids, liquids, and gases, right? Now, solids and examples of solids include stones, chairs, metals, etc. Liquids include honey, urine, water, soup, fruit juice like calipo. Then, when we talk about the gaseous state, this includes all gases. Talk of oxygen, carbon dioxide, nitrogen, water vapor, LPG, etc. Now, all these states of matter have something in common, and that is they are all made up of tiny particles called atoms. Now, atoms are the building blocks of matter, no matter the states of the state of that matter. Okay. Now, note that the atom itself is not the smallest thing that exists on in this universe, right? Because the atom itself is made up of much smaller particles called subatomic particles. Now, I will talk about this in the next lecture. However, we consider the atom as the basic building blocks of matter because the atom is the smallest particle of matter that can exist on its own. Now, what does this mean? Take this chocolate for instance. By the way, this chocolate is produced in Ghana, so if you need some, you can link up. All right, so take this chocolate for instance. If I break any piece of this chocolate, no matter how tiny it is, will taste like chocolate, right? Now, the chocolate itself was made from ingredients such as sugar, cocoa powder, milk powder, etc. Right? But then, if we taste these ingredients individually, none will have the taste of chocolate. Okay, at best, the cocoa powder will come closer, but it is quite bitter. Okay, however, when you mix these ingredients in their right amount, you get this nice and delicious chocolate. Similarly, the smallest particle of matter that retains its property is the atom. Okay, because if you take the subatomic particles, as we will see in the next lecture, for instance, you won't find properties of matter like they don't retain the properties of matter. Is that okay? So that is the reason we consider the atom as the basic building blocks of matter, not because it is the smallest thing that exists, no, because it is the basic or the most the tiniest particle you can get that can exist on its own. Okay, now when we put many atoms of the same kind together, we get what we call an element, which is the subject for the next lesson. Now, I think this is a good place to end this lesson. I encourage you to take some time to do the exercises that follow to test your understanding of the lesson. Now, if you do the exercise and you want me to check your solution, you can send your solution to the email on the screen. All right, thank you for watching. See you in the next lecture.